In statistics, what does DF denote? So DF denotes degrees of freedom. If a simple random sample of size 23, so that's all we need. The sample size is 23. So degrees of freedom, we've been working with it, is one less than the sample size, so it'd be 22. So DF denotes degrees of freedom. For 23 sample size, it's 22. I want to test whether students' textbook costs for this semester are higher on average than the average cost of 450 in the year 2000. What would be an appropriate alternative hypothesis? So I want to test they are higher. So alternative would be whether they are higher or greater than 450. Remember, alternative has one of these inequalities. Null has the equal. Determine the critical values. So many of the problems will be very similar in this section. The only difference is that we are now dealing with hypothesis testing for means. So in the previous section, we were dealing with hypothesis tests for proportions. And so in that case, for critical value, we were using a normal calculator. When you are dealing hypothesis test for mean, you do T calculator for the critical values. So remember, critical values, one of the three calculators has to be used. For proportion stats, we use normal calculator. For for proportion hypothesis or percentage hypothesis, we use normal calculator. And if the hypothesis test is testing means, we use T calculator. In this particular problem, they don't mention any hypothesis, but they're just saying to find the T critical value. So that's obvious that you have to use T calculator. So StatCrunch, stats calculator T. So degrees of freedom is needed. That's 15 for part A. And if it's a right tail test, you put alpha in the right tail. Alpha is the area, tail area. So you put the tail area of 0.10. Degrees of freedom is 15. And make it right tail, so greater than. And the area was 0.1. So 1.341 positive. And then you have a left tail, alpha is again 0.1. And this time sample size is 10. So degrees of freedom will be 9, one less than the sample size. In the previous problem, they gave degrees of freedom, so you just put them as such. And then this one was left-tailed, and alpha was 0.1 again. Alpha is the tail area. So negative 1.383. And then terminal for a two-tail test. Now remember, two-tail we work slightly differently. Instead of putting these alphas in the tails, which we do for right and left tail, in two-tail we know that the total tail area is 0.01. So the in-between tail area, the in-between area would be 0.99. It's 1 minus 0.01. So you put 1 minus alpha in the middle for a two-tailed test. You're looking for two values, so you would be doing the between. and you do 1 minus alpha. So 1 minus 0.01 is 0.99. So you go to between 0.99, you put the area as 0.99. And sample size is 17, so degrees of freedom will be 16. So negative 2.921 and positive 2.921. So plus minus